It's my pleasure to have this presentation concerning the ultrasound-guided attenuation parameter for quantification of liver steatosis in comparison with control attenuation parameter like reference method. We are from the Department of Gastroenterology and Hepatology from University of Medicine, Timișoara, Romania. Why we need to have a quantification of liver steatosis? There are many reasons. Because in this moment it's a focus of the research in this field, because this quantification is requested by physician and by patient. In this moment, fatty liver is a very common problem in medical daily practice, and now the number of patients with liver steatosis around the globe is very high. If we look here, we can have the image of the patient of risk coming from this very on the left statue of Venus, going to the Roman period with this obese patient, and going in nowadays obesity, hypertriglyceridemia, and others are the condition for this situation. If we look at to the obesity and type 2 diabetes in the world, we can see a huge number of world population being obese and overweight. Look to the overweighting, quite 2 billion persons are overweight in the world. Second, looking to type 2 diabetes mellitus, we have now in the world 1 in 11 adult patients in developed country have this pathology. Many patients with type 2 diabetes are overweight or obese, and if they are with obesity and type 2 diabetes, they have a very high risk to have fatty liver infiltration, non-alcoholic fatty liver disease. Looking to this map, it's a lot of deep red here everywhere. Then the obesity is a global problem quite everywhere, especially in the developed country. Looking to diabetes in states, the epidemic of diabetes, we can see here in this southeast part of states, it's a very deep red color here. This a meta-analysis published last year by Anusi. It's interesting here, looking in the type 2 diabetes patient, we can see then 68 of them in Europe are with fatty liver, 51 in States, or 52 in East Asia. Then it's a frequent pathology, and if we look to the global level in the world, 55% of the population with type 2 diabetes have fatty liver. Then how to look for this fatty liver? We have like main method, imaging method. And we can start with very simple method, imaging method that are transabdominal ultrasound, then going to the FibroScan system that have inside the control attenuation parameter, and going to the new modality of quantification by ultrasound that are on the market for 1 or 2 years, and finishing with CT or MRI, PDFF. It's quite a good standard in this moment. When we take the decision which method to use, we must have in mind the cost of this, the availability of this, accessibility, and the performance of I will speak now, I will be focused on this UGAP. UGAP is ultrasound-guided attenuation parameter, and this method is a method for quantification of steatosis. And what this system make, we have some radio frequency signal, and this we have an attenuation, and then we have in this system, from this attenuation coefficient, we make a number. Then we have a number of the severity of this steatosis. You can see here an image. Then in this system that come from GE, we have 3 measurements in the same image. We look to the liver by intercostal wave. We have the look. We have the look of the we have the look of the liver, and here we can put these boxes, and we have 3 measurements, and the results are here expressed in decibel per centimeter per megahertz. Here we have one situation with only one measurement, and again we have here 3 measurements in the same image, ultrasound image. Then we take the image by intercostal way, and then we put the box for the measurement. What is the aim of our study? This aim is to evaluate the usefulness of this new system UGAP from GE that is implemented in logic in9 in comparison with CAP, control attenuation parameter, like a reference method. And why we took CAP? Because there are many papers that show good value of this method, and it's in many places it's in this moment considered to be a reference method. There are some meta-analyses looking to the accuracy of CAP for fatty liver quantification, and there are 2 important. One is published by Xi and the others by Ka. Our cohort consists in 177 constitutive subjects, mostly of them with NAFLD, then steatosis in ultrasound, with half of them being female. And in the same session, we make evaluation of the liver steatosis using UGAP from logic in9 system and CAP fibroscan. For reliable UGAP measurement, we use the same criteria like in fibroscan. Then we use to have 10 measurements in a homogeneous area, and we need to have an IQR per median below 30. We use the cutoff value for discrimination between the degree of steatosis by CAP recommended by manufacturer, and for mild steatosis we have 230, for moderate 275, and 300 for severe steatosis. We can divide our cohort from the point of view of CAP measurement, having quite a homogeneous structure here, 27% no steatosis, 31 having mild, 7% moderate, and 33% of them having severe steatosis. Which are the values that we obtain in UGAP? We can see that the mean value for no steatosis it's below 200, for S1 216, for moderate steatosis 237, and for severe steatosis 270, and this is highly significant. What we can have here, like a comparison, the UGAP mean value are significantly lower than the value that obtained in CAP. Looking to the correlation between the two methods, UGAP and CAP, we can see that it's a strong positive correlation, R being 0.73. And if we like to have some cutoff value from UGAP for predicting different degree of liver steatosis, we found this for mild steatosis 192, for moderate 231, and for severe steatosis 248. If we look to the log for all these cutoff value are quite high, between 0.83 and 0.91. Then the sensitivity and specificity are a little different here, but if we look to the predictive and negative value, these are quite good for practice. Like conclusion, we can say then this ultrasound-guided attenuation parameter from GE that is implemented in logic in9 seem to be a good method for liver steatosis quantification, at least in comparison with CAP. And the next step is this ultrasound system that can make quantification of steatosis are good for our daily practice. And we like this because don't matter that it's GE or it's a Canon system, we have in the same machine the capacity of making ultrasound, but in the same time to make the quantification of steatosis, but this machine can make in the same time quantification of fibrosis. This is a nice image from waterfall from Romania. I will finish with the invitation, a kind invitation, the next year to come in my city, in Timișoara, in Romania, between 26 and 29 of May, when we'll held the World Congress of Ultrasound. Please come to see our wonderful city. That will be the European capital of culture, but will be at the same time the world capital of ultrasound. For your attention. Bună ziua!